In this video, I'll show you how to solve the ALEKS problem called finding density from an FCC or BCC lattice constant. In this problem, we're going to be working with the density of a cubic unit cell. I'm just going to begin with a reminder for the density equation that is going to be calculated by taking the mass of the unit cell and dividing it by the volume of the unit cell. Now, there are going to be different variations of this problem. Some of the problems are going to ask you to calculate density. Some of the problems are going to ask you to calculate the volume, kind of. It's going to ask you specifically to calculate the value of the lattice constant. Some of these problems are going to ask you to calculate the mass, or in my case, identify the element, which is coming from our mass calculation. So be prepared to solve for any one of these variables in the density equation. Don't worry, I'm going to give you enough information that you'll be able to solve whatever type of problem you come across. So let's start by talking about the volume. ALEKS is making this problem a little bit trickier because it's not going to give us the volume directly. It's also not going to give you the mass directly. These are numbers that we're going to have to come up with. The volume, since this is a cubic unit cell, it's a cube, and the volume is going to be the edge length of the cube, the edge length cubed. So I'm just going to kind of write that out. And the edge length is our lattice constant. So this number right here. If you have been given a lattice constant, that means that you have the ability to calculate the volume. So to calculate the volume of our cube, we're going to take that lattice constant and we are just going to simply cube it. Now we do need to do we're going to need to do a unit conversion because in this density equation, our volume needs to be in units of cubic centimeters. That's going to be the standard unit for calculating the density of a unit cell. And you can see that ALEKS is going to give you that A value in units of picometers. So the first thing that I'm going to do with this problem is take my lattice constant, my edge length, in picometers, and I'm going to convert that into centimeters. 1 picometer is 10 to the minus 12 meters. And then I'm going to do one more conversion. 1 centimeter is 10 to the minus 2 meters. And that's going to get me my edge length in units of centimeters, which is consistent with what I'm trying to work with in this problem. 408 times 10 to the minus 12 divided by 10 to the minus 2. This gives me an edge length, or an A value, of 4.08 times 10 to the negative 8. And then again, to get the volume of this unit cell, I'm just going to take that edge length that I just calculated and I'm going to cube it. So my volume is going to be A cubed, which is 4.08 times 10 to the negative 8. And I'm going to cube that. And, oops. Oh gosh, there we go. That gives me a volume of 6.79 times 10 to the negative 23, and those units are cubic centimeter, right there. So for my problem, I'm just going to make a note of that, 6.79 times 10 to the negative 23 cubic centimeters. So a lot of the versions of the problem that I saw, these versions were actually asking us to calculate the density. So if you are looking at that version of the problem where you're being asked to calculate density, you're going to need to do a volume calculation like I just did, and you're also going to need to do a mass calculation. And the mass calculation is a little bit tricky. So let's kind of walk through where that comes from. That mass calculation, this is asking for the mass of the atoms that are in the unit cell. Now, ALEKS is going to tell you what the element is in the unit cell. Like maybe it's going to say it's a unit cell of iron, or maybe it's going to say it's a unit cell of gold. And what we need to do is calculate the mass of all of the atoms of iron that are inside your unit cell. So first of all, first thing that we have to do is recognize for these two different types of unit cells, we've got possibly a face-centered unit cell, we've possibly got a body-centered unit cell. If you have a body-centered unit cell, that unit cell has 2 total atoms, or the equivalent of 2 total atoms inside that unit cell. A face-centered unit cell has the equivalent of 4 total atoms inside the unit cell. So a unit cell, a body-centered unit cell of iron is going to have essentially 2 iron atoms in it. A face-centered unit cell is going to essentially have 4 iron atoms in it. ALEKS is going to tell you what type of unit cell you're working with, unless maybe, I guess maybe that's possibly your unknown variable. That's definitely possible. But probably ALEKS is going to tell you what unit cell you're working with. And so for me, I'm working with a face-centered unit cell, which means that I have a total of 4 atoms inside my unit cell. And for a lot of versions of the problem, you're going to know what that atom is. So what you're going to need to do is figure out how much one atom weighs and then multiply that by the correct number of atoms based on what type of unit cell you have. So that calculation is going to look like this. You're going to go to the periodic table. You're going to look up the atomic mass of your element, whatever it is, like you'd look up the atomic mass of iron. You're going to recognize that that number is the mass of a whole entire mole of those atoms, not just one. So you're going to take the atomic mass and you're going to divide it by Avogadro's number, 6.022 times 10 to the 23rd. That's going to give you the mass of just one single atom. And then you're going to multiply that by either 2 or 4 based on how many atoms you actually have in your unit cell. So the atomic mass divided by Avogadro's number multiplied by the number of atoms in your unit cell. And that is how you are going to calculate the mass of your unit cell. So all of this right there. Now, it is possible, depending on the variation of the problem that you have, it's possible that this is the unknown for your problem. And for me, it's my unknown. My job is to figure out what element I have, and the way that I'm going to do that is by calculating the atomic mass of my element. And I can totally see that it would be possible for ALEKS to be asking you what type of unit cell it is, face-centered or body-centered, in which case this is the number that you would be determining. This would be your unknown variable because the number of atoms in the unit cell is going to let you know what type of unit cell you have. So there's a lot of math going on in this problem. I really like it a lot. Okay, so for me, I can't calculate the mass because I don't know what element I have. I don't have iron. That was just an example. I don't know what element I have. What I do know in mine, I do know the density that was given to me in the problem. So I am going to take this density equation. I'm going to rearrange it to isolate my unknown variable. So I'm going to say density times volume is equal to mass. I'm just using cross multiplication there. The density times the volume is equal to the mass. And I am going to plug in the density that I was given in the problem, which is 19.30, and those units of grams per cubic centimeter. I'm going to leave the units off just to save space on the screen here. And then I'm going to multiply that by the volume calculation that I did earlier. So I'm going to be multiplying that by 6.79 times 10 to the negative 23rd. Again, I'm leaving my units off. And this is going to give me my mass, 19.3 times 6.79 times 10 to the negative 23rd. This gives me a mass of 1.310 times 10 to the negative 21. Now, recognize that this number that I just calculated, that's the mass. That is all of this business. So 13.1 times 10 to the negative 21 is equal to the atomic mass divided by Avogadro's number times the number of atoms in the unit cell. So I'm not done. I've got a lot more math left to do. So this is equal to the atomic mass. Let's just abbreviate that, atomic mass, AM, divided by Avogadro's number, 6.022 times 10 to the 23rd, times the number of atoms in the unit cell. So ALEKS told me I have an FCC unit cell. FCC unit cells have a total of 4 atoms in them. So I've got 4, I'm going to put right here. This problem is a bit of a beast. And what I'm solving for now is the atomic mass. So I'm just going to, let's see, I'm going to begin by multiplying both sides of this equation by 6.022 times 10 to the 23rd. I don't know why I tried crossing that off. That was silly. 6.022 times 10 to the 23rd. And so that's going to give me 789.2 is equal to my atomic mass, which I don't know, times 4. I'm going to divide both sides of the equation by 4. And this gives me 197.3 as my atomic mass. Now that I know the atomic mass and the problem is asking me to identify the element, and now I need to go to a periodic table and I need to find the element that has an atomic mass of 197. which is, looks like it is gold. So this problem, there's a lot of math in this problem. There's a lot of algebra in this problem. What did I say it was? I said it was gold, I think. We'll go back and look at it again. Gold, yes. So this problem has a lot of different potential for what ALEKS might ask you to solve for. It might be asking you to identify the element, which means you have to solve for atomic mass. It might be asking you to identify the unit cell, which means you solve for the number of atoms in the unit cell, and then you use that number to figure out the type. It could be asking you to solve for the lattice constant, which is the edge length, which you would get from the volume, or it could be asking you to just simply calculate the density, which I don't know why I say simply, because that's pretty tough as well. But take your time with this problem and good luck.